All right, today we're doing part two of lesson 12, and we're talking about, like I said yesterday, we're talking about interquartile range. Um, this is kind of the second way of analyzing data that we're going to take a look at after we already discussed MAD, the mean absolute deviation. So, again, in the name is a lot of what we're going to be doing today, and I think that'll make sense pretty quickly um, as we get into calculating this. So we're going to work a little bit out of order here. So please find this page. This is the second page in your packet for lesson 12. And we just have a few notes to fill in. So please fill in with me. We've got the IQR is the middle half of the data and is centered around the median. So we're going to be using median, whereas in our last lesson, we were finding the mean again and then finding the mean absolute deviation. We'll do that again today some more. This is around the median. Remember, that's the very middle of the data when the data is in order from least to greatest. So let's look at an example. I think it'll start to make sense very quickly. It says to find the interquartile range of the average high temperature in Seattle, Washington. Now look over here in the box. We're going to fill in with the steps on how to do this. The first thing we have to do is we have to order the data from least to greatest, which is what we would have done to find the median. We have to order those numbers, that data from least to greatest. Now this part does seem pretty simple, but it's very easy to overlook numbers. So I would suggest always marking the numbers that you're writing so we don't leave something out. And if there's two of them, we make sure to include both of those values. So I'm looking for the lowest numbers right now. I've got two 46s. So I could cross them out or put a dot next to them so that I know I've included it. All right, we're going to keep, that's all my 40s. Then we have 50, 51, 53, and 58. Don't see any more. Then we go into the 60s with 60 and 64. Two 70s. I'm running out of space here. A 75 and a 76. Okay, so those are all listed least to greatest. The next thing we're going to do is just like we would when we did this in a couple lessons ago, is we'd find the median. And remember, that is the very middle of our data. So we're going to work from the outside into the center from both directions and find that middle quantity. Now, the one thing I'm not going to do is I don't want to cross out these numbers because I'm going to need them as I work forward. So I could count and say go in 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, like that, and keep working towards the center. So we'll go in, and my median is going to fall right here between 58 and 60. So my median is 59. All right, so we found the median. I'm going to mark that just so we're clear on what we're doing here. Then we find the median of the lower and upper quartiles. That's over here on this third step. Okay, so what that means is now we're basically going to consider the lower half, and we're going to find the median of that data, and then we're going to look at the upper half and find the median of that data. So we have 1, 2, 3, 4, 5, 6 values. So my midpoint, we'll use a different color, is going to be between the 3 values here and between, well, 6 on the right side as well, so it'll be there. All right. On the lower quartile, we have between 50 and 51. So that would be 50 and a half, 50.5. That's quartile 1. And then on the upper, we have between 70 and 70. Well, nothing's between 70 and 70. So 70 is our quartile 3. All right. Now we're almost done. We have one more step, and that is to subtract to find the middle half. The middle half. And the middle half is going to fall. If you look at this, we have our data in really 4 groups. Okay, you can see that each of them is a group of 3 quantities, 3 numbers, and our middle half is going to be these center 6 values here. So that is going to be our IQR, but it's going to be the range between it. Okay, so we're going to go between 70 and 50.5. That's what the 2 numbers that we're subtracting to find this range between here. So we'll take 70 minus 50.5 and get 19.5 IQR. All right, and that would answer that question there. So that's how you find IQR. We are going to do a couple more examples of that, and we have some more notes to fill in. So what we're going to do is take a look at the rest of this page first. I do want to review MAD with you, mean absolute deviation, because we did that in the last lesson a lot, but it's certainly good to kind of refresh your memory. So let's do this one together. We'll do one more example of IQR before you try it, and then fill in a few more notes before we continue on. All right, so continuing on into the practice questions, the following data set represents a number of green M&Ms in 10 snack size bags. So we have our 10 bags here. Each of them has this number of green M&Ms. Then we have, and this is where yesterday we crossed off this first column, the deviation from the mean, because some of these are going to be negative values. And since we know we need the absolute deviation, or only positive values, the distance from that mean, this is really what we're going to do. We're just going to put that value in its absolute value form. It doesn't matter if we're above the mean or below the mean. So let's look at this. The first thing we have to do, remember, with MAD, mean absolute deviation, is we have to find the mean of the data. So here's our data. We need to find the mean of it. We need to combine all these values and divide by 10. So we'll add all these up, get our sum, and divide that by 10, and that will give us a mean of 6.8. So there's 6, on average, there's 6.8 green M&Ms in a pack of M&Ms. Now we need to find the deviation. So how far away are each of these values from our mean? Well, 7 is above our mean, but it's only above by 0.2. 0.2. All right. 9 is above it by 2.2. Okay, and I could just be subtracting this 9 minus 6.8. If I go below it, I could reverse that just to not get a negative number and do 6.8 minus 4. Really, this would be a negative quantity with our deviation, but again, we're getting the absolute value. We're going to write it as a positive value anyways. So we're just going to skip that step. So I'm going to fill all these in. And then if you remember, our last step is to find the mean again. But the mean this time is going to be of the values that we're writing this time. So all of these deviations are going to be combined, added up. We'll get our total and divide it by 10, and that'll give us a mean absolute deviation of 3 4/100, 3.04. All right, that's how you find the mean absolute deviation. Again, that last step was to add up these numbers that we found, these deviations, and then we divided it by 10 to get the mean of these numbers. All right, let's move on. We've got another example where it's talking about finding the median and the IQR. All right, so we will look at this. It says the following data set represents the number of cars running the red light at the intersection of Main Street and Avenue A over a period of 2 weeks. All right, let's find the median. The first thing we have to do is we have to order these numbers from least to greatest again. So I'm going to find that 6 is my least value. Then we have 8. Then there's 2 9s. Okay, you can make sure to mark off those numbers as you're writing them out. You can count all these numbers and make sure you get the same number that you had here originally in the data so you didn't leave something out or forget about it. And now we're going to find the median, the middle set of data. Again, if it's one of these numbers, great. That'll just be written down as our median. If it falls between two numbers, then we'll have to find the value between those two amounts. So I don't want to cross them off. I'm still going to need to use these numbers. So I'm going to count, say 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Working my way towards the middle, do 2 and 2, and that makes my median right here, right between 12 and 14. So my median is 13. Then I need to find my quartiles. So I'm going to look between the lower half and find the median of that and find the median of the upper half. So if I do that, we'll do 1, 2, 3, 1, 2, 3. That leaves this as my first quartile. 1, 2, 3, 1, 2, 3. So I'm working into the middle, and that makes this my upper quartile. All right, now I have my 4 sections of data here, and I just need to find the range between them. So between 9 and 18, how far of a spread is that for my data? I could just subtract 18 minus 9, and my IQR is 9 in this example. For this next one, I want you to give it a try now. This is a frequency table, so remember these little tally marks, these little tick marks represent how many of these numbers we have. So if there's no tally marks, these are not numbers in your data, so please keep that in mind. And I'm just going to write the number of tick marks here just so there's no confusion because the little markings are pretty close together. So there's 2 of these. There are 4 of these, 8 2s, 2 3s, 3 4s, and 1 8. Okay, so when you write out these numbers from least to greatest, remember there are 2 zeros. You need to put 0 twice as you list out all those numbers in order from least to greatest. Go ahead and solve that. Okay, what you should have found is that your median was 2 when you lined up all those values. And then when you looked between Q1, first quartile, which was 1, here, let me do this. So I'm not going to write out all the numbers, but we know the median is 2, quartile 1 was 1, quartile 3 was 3, and the range between 1 and 3 is also 2. Here, the median and the IQR are the same. Okay, now remember what that means. So we're talking about how spread out all of this data is. We're ignoring some of these outliers that are really low and really high in your data. And we're looking based on the center of our data, how spread out is all this information? Okay, if all of our numbers were really close around the median, our IQR would be very low because we're talking about values that are close to that median of the numbers. Okay, if it's a big IQR, that means that our quartiles are very far away from the median, and it's just not as good a data. We want that closely grouped data, just like we talked about with MAD, with mean absolute deviation. Okay? Now, jump to the back of the first page of lesson 12, please. We're going to fill in some notes, and then I would like you to try the problem at the end where you're calculating the mean absolute deviation for these two basketball players. So it says the measure of spread or the measure of variability, something we talked about yesterday, range and the interquartile range are statistics used to measure the distribution of the data in a set. This is just a fancy way of saying what we've already talked about. Now, when a measure of spread is high, that means that the data is spread out or not consistent. That's bad data. That's hard to make assumptions about when it's so spread out. When the measure of spread is low, then that means that the data is not spread out or it's consistent, and that's much easier to make interpretations of. So we're going to look at an example. We have two basketball players, and here are the numbers of points scored over 5 years for NBA players. So this is their 5-year totals for the number of points each year. We're going to find the mean for Kobe Bryant and LeBron James, and we're going to write that here on the line. Now the mean is going to be, again, getting the sum of these values, dividing by how many values there are, which is 5 for the 5 years. So for Kobe, you should have gotten 2,321. And for James, it was 2,268. All right, now based on the means, what we just found here, who's the better scorer per year? Well, Bryant has a higher average, a higher mean for his scores each year. That seems to be the case, so we would say Bryant. But the NBA team likes consistency from their players. Okay, remember that's a low spread in the data, so we're keeping the numbers pretty consistent over these 5 years. Consistency helps the team to accurately measure expectations. Interquartile range for both of these players is going to help us figure that out. So we need to find our center value. Luckily, these are already listed from least to greatest for both of them. So we have, let's work in a different color here. We have our median is our center value here for both. Our first and third quartiles are going to fall between both halves there. So we just need to find the value that would fall directly between these two numbers. Okay? Now, what we could do to find that is we could add them up and divide by 2, and that would tell us what would fall right between them. So let me do that real quick. So I'm going to add 1,819 to 2,201, divide that by 2, and my Q1 is 2,010. All right, then I'm going to do the same thing for the upper quartile. I'm going to add the 2430 to the 2832, divide it by 2 to find the midway point there that I'm looking for, and that is 2,631. So for Bryant, I'm going to get the IQR by subtracting these two interquartiles. Okay, so I would subtract 2,010 from 2,630, and Bryant's IQR is going to be 621. Now I want you to go ahead and find that for James. So determine this Q1 and Q3, and then go ahead and take it a step further and determine the IQR, the range between those two marking points. Okay, hopefully when you subtracted those, you got 237. And now we see that James has a lower IQR. And remember, when that is a lower number, it's a lower spread. So that means that James is a more consistent player. If you look at his numbers, we have in kind of the low 2000s all 5 years. That's pretty consistent over a season. Where here, Bryant was down below 2000 and then almost up to 3000 on one of those years. So that's a much wider spread of data. That's why his IQR is bigger. So if we were answering that based on the results, which is a more consistent score, that would be James. It's more predictable that he's going to get close to 2,000 points in a season. All right, for the next part, we talk about mean absolute deviation. This is a review again. And it's the average of the absolute values of the differences between each data value in a data set and the set's mean. Basically, we found the mean of data and then decided how far each value was away from it. Okay, it says, in other words, it's the average distance that each value is away from the mean. So let's fill this in before you go ahead and calculate for the two players. So if a data set has a small mean absolute deviation, then the data values are relatively close to the mean, and that makes the data consistent. If the data set has a large mean absolute deviation, the values are spread out and far from the mean, which makes the data inconsistent. Remember, good, bad. All right. Now, I want you to go ahead and find the MAD for Bryant and for James. Based off of their 5-season totals, go ahead and remember to find the mean first, then the deviation from the mean for each of the 5 values, and then find the mean again to get our mean absolute deviation. Okay? Determine which of these players, because this is the point, which of these players is more consistent using mean now instead of IQR. All right. After you did all that work, you should have found that the mean for Bryant was 2,321. And when you calculated each of the deviations for those 5 years and found the mean of that, you get 248.8. Now for James, his mean was 2,268. You would find the deviation for those 5 years, which again means how far is each of these numbers from the mean. That's what you would write here. Add them all up, divide by 5, and our mean absolute deviation for James is 98.4. Okay, if you go back to what we just described for mean absolute deviation, it's the same as IQR. And what we're saying is the lower this number is, the more closely grouped the data is. So we're again proving James is more consistent in scoring. It's not spread out, so he's a more reliable player. You can count on the consistency of what is expected for the year, where Bryant is more inconsistent and a little less dependable on what the season. It could be a very good season or a poorer season. So that's it. That's today's lesson. I hope it helps. Please finish your practice problems for lesson 12 if you haven't already. And we will continue on to a few more things in statistics before our quiz at the end of the week. Everybody have a great day.